Hello and welcome once again to Special Maths Academy. And today's video, we are going to start the problems series on the just concluded junior second round Maths Olympiad 2021. So we solve all the questions in this playlist and upload it. The first question on the exam was this. So we are asked to evaluate this, find the value of this sub or simplify this. So as you can see, there are a lot of radical surds here, and it's not so easy to simply say what the answer is. So the best way of approaching this question is try to simplify this question from the innermost surd. So we're going to try to check if we can simplify this. Then after we simplify this, we expand this 4 times the simplified version, and we now try to check if we can simplify this, and we try to check if we can simplify this before we now finally do the question. So we are starting from innermost to the outermost surd, not the other way around. That's just a good way of attempting this type of surd questions. So the first step we have to do is, can we try to simplify this? That's the first thing we want to try to do now. So now, a way of doing this question is to try to assume, let's say, suppose there exist A and B member of positive real numbers such that this is this. We want to try and check if we can find the square root of 3 minus root 2 as square root of a number minus square root of another number. Notice how I'm saying it, I said if we can find, if we can express it in this form. We can always find the square root of this, but the problem is that we may not know how to express the square root of this. So this type of way I'm writing this is like an assumption. If we can't express the square root of this in this form, it doesn't mean this doesn't have a square root. It just means we can't express it in this form. So what I'm saying here is an assumption. Saying suppose we can express it in this form. So where A and B are positive real numbers with some other properties. So this whole idea is just a bunch of assumptions. So I just want to try to explain it very well. So now, and as later on, I'll add up the other properties that A and B have to satisfy to make this whole assumption compact. So now, if you want to say, okay, this equals to this, or identical, actually, it's meant to be identical, they are both equal. So usually when you see something identical, when you reach a point, you now start comparing some kind of thing. So that's what we do here. So now let's square both sides, and if you square both sides, we're going to get this. Okay, and the reason why I put the negative sign here is because the sign here was negative. The sign here was positive. I could have tried to have checked if you can find numbers A and B such that is the sum of 2 surds. But because the sign in between are negative, and I know that if you square it, we have negative something. That's why I put negative here. Remember, we started this whole something all from an assumption. So we should always keep that in mind. So now, from here, this is what we have. I know some of us may have already seen it in some textbooks that, okay, we now compare, this has to be equal to this because it has no radical, it's just alone, and this has to be the same with this. Then we solve some equations together and we get values of A and B. But the problem is that we have to make sure we add it in this assumption, because let's say, for example, the only property here is that A and B are positive real numbers. A can actually be a surd itself, maybe root 2 or something like that. So this general stuff, we have to actually add it up into this place. So I have to say A and B, I have to add it up so to be very compact. Because a lot of us we just compare coefficients and all that, but A and B, there's no property here that says A and B cannot be surds. So that's why we have to add it up here. A and B are not surds. I don't know what they call such numbers. A and B, non-surds. And also there are some values of A and B that are non-surds, but there are some values that A and B can take that. Okay, let me just say, okay, for example now, if A is let's say 5 and B is let's say 3, it's let's say 15. Let's say 45. Yeah. So comparing coefficients, I want to try to explain this comparing coefficients well. If A and B are this and this, square root of A is not a rational number, square root of B is also not a rational number, but square root of AB is a rational number. So like that can also like cause a problem. Because like now, let's say if square root of AB were to be a rational number, we can't like say this is to be equal to this. Why? Because this will be a rational number, but this will not be a rational number. So that's why we have to like add that assumption here also. And AB or square root of AB is irrational, or is a surd. It's a surd. We have to like add it here also, because like this example I gave now, if A is like to be 5 and B is to be, let's say, 45, square root of AB is not rational, but that's why we can't like just generally conclude compare coefficients here. We have to like add all these assumptions here, but usually we don't add all this. So this is like the whole bunch of assumptions that this whole thing has to work on. That, but remember, as I said earlier on, if upon all these assumptions we don't like find a value of A and B, means like we can't express it in this form. So it's after we have written all these assumptions above that we can now confidently like start comparing coefficients. Now when we compare coefficients, we get that A and B, like A plus B has to be equal to 3, and minus 2 root 2 has to be equal to minus 2 root AB. So that would mean that root AB should be equal to 2, which should mean AB is equal to 2. So A plus B is 3, AB is equal to 2. There are a lot of ways of finding A and B, like so we can select AB equals 3 minus B, then plug it in here. So B 3 minus B is equals to 2. So get that B squared minus 3B plus 2 is equals to 0. Then from here, I'll get B minus 1. B minus 2 is equals to 0. So it implies that B is equals to 1 or 2. So if B is equals to 1, just standard way of solving it. If B equals to 1, A is equals to 2. If B equals to 2, A is equals to 1. So there are two solutions to this equation here. So this is system of equation here. There are two solutions to the system here. But remember, let's look at this equation here again now. Let's check if both of them work. You know that like square root of 2 is between 1.5 and 1.4. Like we all know that. Yeah. So it means that 2 square root of 2 is between 2.8 and 3. So it means that 3 is bigger than 2 root 2. So it means that like this number here is positive. So like we're safe to take square root. I know that square root of any positive number should also be positive. So it means that this right-hand side should also be positive. So it means that root A should be greater than root B, which should imply that A is greater than B because both of them are positive. So A should be bigger than B. So that means that cancels out the second case here. So it means that A is equals to 2, B is equals to 1. So and also we have to like try to like make sure that all these assumptions here still hold. A and B are non-surd, 2 is a non-surd, 1 is a non-surd. Like yeah, like you can write as root 4, but like you can stand alone, like you can express in a form that is a non-surd. Let me say something like that. And AB is 2, so square root of 2 is a surd. You can't 2 is not a perfect square. So it satisfies all the properties of this assumption here. So we are good to go. So it means that we can express it in this form. Root 2 minus root 1. Or can root 1 is empty on 1, so we can just write as this. And to verify, you can square this and you easily see that you get this. So this is the square root of 3 minus 2 root 2 in this form. So what we're going to do now, we're going to now, let me just clean this out. So what we're going to do now is we're going to now put this is the same thing with square root of 2 minus 1. So let me write it here. So let's write it here. So square root of 3 minus 2 root 2, we found out that it was called square root of 2 minus 1. So that is the first step. Now let's plug it inside here. So the expression becomes square root of 9 minus, or let me just write this innermost stuff here. So we can now start working with it. 10 plus 4. And this is root 2 minus 1. So this is what? Root 10, right? Root 6 plus 4 root 2. Right? This is what we have. So this is what we have. So next up, we should try to like find the square root of 6 plus 4 root 2. Then I won't like re-explain all these things well again, like deeply, because I earlier did that in the first square root. So I believe you just Similarly, like all those assumptions, like still have to hold for what we are doing here to like fully be compact. So let's say it's equals to square root of x plus square root of y. So I'm using plus now because the sign here is plus. So when I square both sides, I get 6 plus 4 root 2 is equals to x plus y plus 2 root xy. So from here, comparing coefficients, we get that x plus y is equals to 6, 2 root xy is equals to 4 root 2. Right? Yeah. So root xy is equals to 2 root 2, which is same as root 8. So xy is equals to 8. So x plus y is 4, x plus y is 6, xy is equals to 8. X plus y 6, xy is equals to 8. Then by Vieta formula, x and y are both roots of this equation. A squared minus the sum of roots, like when x and y are both roots, so the sum of roots will be 6. A plus the product of root will be 8. So they are both the roots of this equation. So let's work with this equation now. What are the roots of this? Or let's factorize this. We get that this. So we see that 2 and 4 will do things properly. So A is equals to 2 or 4. So A is equals to 2 or 4. Yeah. So it means that x is and y are both true. So it means x equals to 4 too. So when x is 2, y is 4. When x is 4, y is 2. But as you can see in this case, because this is symmetric, this is plus, like it doesn't really matter. So both of them are basically the same thing. So what does that mean? It means that square root of, let's write it here now as a new discovery again. It means that square root of 6 plus 4 root 2 is the same thing with what? Square root of 4, which is 2 plus square root of 2. Doesn't matter, I can write square root of 2 plus square root of 4. It's the same thing, it's addition. So we are safe there. So it means this is what we have as a square root. So now let's come back here again and let's plug it in. Let's plug it in now and see what we'll get. So it means that this whole thing here is this. So the innermost bracket square root now, innermost surd now become this 6, 2 plus root 2. So this will be what? Square root of 11. So that is 23 minus 12. That is 11 minus 6 root 2. Let me just confirm. Yes. So this is what it will be. Okay, this is what this 23 minus 6 plus 2. Okay. And plus. Okay, I just paused to confirm it. Yeah, it's actually correct. Yeah. So we now have to like find square root of 11 minus 6 root 2. So it's just we have to like be careful because as I had to even like carefully look at it. Once we make a mistake here, like especially at this beginning point, like our final answer will be wrong. But a good rule of thumb is that like if you can't find a square root that can be expressed in this form, then most likely you made a mistake along the way. Or even if you find the square, like even if you for each case you find like a possible square root, there's still a chance you made a mistake, but the chances they are lower. So just like have to try and make sure we are very careful in this. So we can try to do this as this again. So I'm putting minus here because there's minus here. And when we do this together, I'll get that A plus B should be at least 11 and AB should be so that will be minus 2 root AB should match it up to this. So that will be root AB should be matched up with 3 root 2, that will be root 18. So AB should be 18. So recall like A and B should now both be roots of this equation. Let me say different variable because I have A here. So x squared minus 11x plus 18 is equals to 0. And this can be factorized as x minus 2, x minus 9. So remember, A has to be bigger than 2. And the positive values of A and B are both either 9 or 2. So A has to be 9, B has to be 2. A is equals to 9, B is equals to 2. So we can now write it here as a new observation. So like square root of 11 minus 6 root 2 is equals to square root of 9. That is 3 minus square root of 2 is square root of 2. We can't further simplify that. So then from here now, we now write our latest surd that we're working with. So we get that this, and actually it's like the outermost one because we have simplified this, we have worked out with this. Remember this outside one, like the final the surd. So this will be 9 minus 2, 3 minus this. So this what square root of 3. It's 3, right? Let's make sure I'm not making any mistake. 3. Okay, this is meant to be root 2, not 2 root 2. Exactly. 3 plus 2 root 2. So this is what we have now. It looks very similar to what we did here, but we just do it again for completeness sake. So the final answer to this is square root of 9 plus is this. Now like square root of 3 plus 2 root 2. So let's check for square root of 3 plus 2. So because there's a plus in between, we now have to put a plus here and get that a plus b should be equals to 3, as we've always been getting, and this should be equals to this. So AB should be equals to 2, and we have solved this equation before, and we got that A can be 2, B equals to 1, or the other way around, because there's a plus here, so the order doesn't really matter. So what we have here is that the square root of 3 plus 2 root 2 equals to square root of 2 plus square root of 1. We just write as 1. So it means that the answer to this question is basically square root of 3 plus 2 root 2, as we found out, because we started from the innermost and we kept on finding. So the answer to this question is answer equals to square root of 3 plus 2 root 2 plus root 2 plus 1. So this is the answer to this question. As I said, like there was nothing so technical here. Like the only technical issues here was like us making this assumption, and I tried to like find all the constraints that this assumption that this A and B should satisfy to like make the assumption like foolproof, like concrete, because usually people don't really talk so much about these other conditions. That's why I tried to explain using the first example. The other ones was very, very similar. So this is how we do the question. The answer to this is this. As I said earlier, we have to try to be careful as much as possible. And we have to like start from the innermost, because we couldn't definitely have started from this outside sword. So we have to like go in, and we're a bit lucky that there are not so many swords here, so it was feasible to do all of them manually. And that's what we just did now. So thanks for joining me in this question, and I'll see you in the next question.